Okay. Okay. So in the transient analysis, we are on the second part of the circuit, and that is RC analysis. So let's go to the RC analysis again, and let's take few more example on RC analysis. So we are here to analyze the transient. Transient. In transient, we are analyzing the first order circuit, and first order circuit comes in two categories. The first one is RC circuit and second one is RL circuit. So yesterday we have talked about RC circuit, RL circuit. Now we are talking about the RC circuit. And let's take few more example, few good examples on RC and RL circuit. And second example is this. We are having a new variety of problem here. In this problem, our source is also exponentially decaying in nature. So this is our source. The value of the source is e to the power minus t. It is given in the question. What else is given? This value is 1. This value is half. Then we are having one capacitor. And capacitor value is 1 farad. They are calling that the voltage across capacitor is plus minus of VCT. Correct. Again, one more thing is given. VC 0 minus means we don't have to analyze the circuit for t less than 0. This value is given as 0.5. And in this type of circuits, we need to solve the differential equation. You cannot solve this question, this type of questions directly. And what else is given? They want to analyze the VCT. The question is VCT for t greater than or equal to 0. And here a switch is connected, and what is the position of the switch? The position of the switch is this. At t0 minus, this tel represents the condition of the switch for t less than 0, and the head of the arrow represents the condition of switch at t greater than 0. So can I say, because only we are having one energy storing element in the circuit, if we are having only one energy storing element in the circuit, so and energy of that element is given or stored voltage across that element is given, so we don't need to analyze the circuit for t less than 0, because all the information, two components are instantaneous component, only one component is energy storing element, and the condition for energy storing element is given. So directly we will analyze the circuit for t greater than 0. If I analyze the circuit for t greater than 0, how circuit will looks like? I am having one source which is e to the power minus of t, correct? Then what we are having, 1 ohm resistance is here. Then we are having 1/2 ohm resistance. Then we are having one capacitor, and one capacitor of value of how much? One capacitor of value 1 farad. These are standard problems. After solving these problems, we will analyze the easier question or the gate question, and we will see the all type of shortcuts. VCT. Correct? This is our problem. So there are two choices for analyzing any circuit. You can apply the KVL or you can go for the KCL also. But if I use node, how many nodes are required to analyze this circuit? So can I say we need only one node. If I consider this whole voltage as my reference voltage, if I consider my whole voltage as reference voltage, I can say this whole branch is available at which potential? This whole branch is available at potential VCT. Yes or no? And a simple KCL can be applied here. When you apply the KCL, we can say what is the current in this branch. So KCL says that sum of current at a node is always equivalent to 0. If sum of current at a node equal to always equivalent to 0, so can I say there is no current going or coming from the open loop. So sum of this three current equal to 0. The sum of current of this branch plus this branch plus this branch is equivalent to 0. So you can say VCT minus e to the power minus t divided by 1 is current in which branch? The current in this combination, e to the power minus t and 1 combination. What is next? VCT higher potential minus lower potential divided by resistance. And what is resistance here? 1 by 2 ohm is the resistance here. So current in this branch plus current in this branch. What is current in this branch? Current in 1 farad resistance is what? C dV by dt. So d VCT divided by dt multiplied by C, and C is 1. So sum of this current is equivalent to 0. This is the formation of differential equation, and we need to solve this differential equation. Correct? If we need to solve this differential equation, how we will solve it? As we know, dVCT divided by dt is given. So let me write the differential equation here is dVCT divided by dt plus 2 VCT plus VCT is what? 3 VCT. Okay, dVCT divided by dt plus 2 VCT plus VCT is 3 VCT equal to what? E to the power minus t. Your all kind of shortcuts are not valid when you are having this type of problems. Always remember, the shortcuts are valid for only a certain kind of problems, not all the problems. So just we are analyzing all the problems without any shortcut, just by the conceptual understanding. Only the differential equation of the first order and your basic knowledge of capacitor and inductor can solve any kind of problem related to the transient. Correct? Now we know that what is the format of the differential equation? The format of the differential equation is this: dxt divided by dt. I am writing it again and again so that you can remember it, plus p times of xt equal to q. And what is solution of this differential equation? As we know that integrating factor is given by e to the power minus e to the power integration of p into dt. In our case, p is equivalent to 3. So e to the power 3t is the integrating factor. And if e to the power 3t is integrating factor, or here we can write e to the power pt is integrating factor. Let's don't break the sequence of this. E to the power is pt is integrating factor. So what is solution? Solution is xt multiplied by e to the power pt equal to e to the power pt into q into dt. And of course, when you differentiate it, you will add one constant of the indefinite integral. So can I say, in our case, we can write what is the solution? VCT into e to the power 3t, because what is our integrating factor? Our integrating factor is e to the power 3t. Integration of this e to the power 3t is integrating factor multiplied by q, which is e to the power minus t into dt. This is the solution. When I solve this, this will be what? E to the power 2t minus t is e to the power 3t minus t is e to the power 2t into dt. And when I solve this, it is e to the power 2t divided by 2 plus 1 constant of the integral, indefinite integral, equal to what? Equal to VCT into e to the power minus of into e to the power 3t. Correct? When I solve this equation, I can write VCT equal to e to the power minus of 3t, and e to the power minus 3t is multiplied by what? E to the power 2t divided by 2 plus k. Always remember, we have to calculate the initial condition after adding CF and PI. So you don't need to focus on CM and PI differently, because we have overall solution. So e to the power minus 3t and e to the power t is e to the power minus of t divided by 2 plus k times of e to the power minus 3t. Now this is your complete solution. But again, we are interested in what? Initial conditions. Again, we are interested in what? Initial conditions. And initial condition for the capacitor, the voltage can be initial condition. And how you define the voltage? The voltage can be defined by, it is given. What is the voltage? VC0 minus equal to 0.5 volt. So can I say VC0 minus equal to VC0 plus is given as half volt. If this value is given as half volt, if we write the solution, VC0 plus equal to e to the power minus 0 plus divided by 2 plus k into e to the power minus 3t. Correct? VC0 plus is already given, it is half volt. So half volt and e to the power 0 is also half volt, cancel. So what is value of k? The value of k is 0. If value of k is 0, what is the solution? Solution is e to the power minus of t divided by 2 for t greater than or equal to 0. This is the voltage across the capacitor we are having. This is the voltage across capacitor we are having. I hope this is clear. Now we are interested in, let's say this is the discussion about the voltage across capacitor. The same voltage is available at 1 by 2. So we can find the current also. If voltage is available, can I say, if voltage is available, we can find the current also. The current VCT is e to the power minus of t by 2 for t greater than or equal to 0. And what kind of circuit we are having? We are having this kind of circuit, that here we are having one source, its value is e to the power minus of t. Then we are having 1 ohm resistance. Then we are having 1 by 2 ohm resistance. Then we are having what? Then we are having 1 farad capacitor. and we are saying that we know this voltage. We are saying that this voltage is VCT, and we know this voltage VCT. This VCT is what? E to the power minus of t by 2. If we know this voltage, we can calculate everything. Means what is the value of current? So if we are interested in the current in the circuit, can I say the current in this branch is given by what? Current in half ohm resistance. The current in half ohm resistance is given by e to the power minus of t by 2 minus of 0 divided by 1 by 2. So this current is 2 into e to the power minus of t by 2 for t greater than or equal to 0. This is the amount of current you are having inside the capacitor. Now, what is the current? What is the current in this branch? So you can say the current in 1 ohm resistance, current in 1 ohm resistance is given by higher potential, which is e to the power minus of t, minus lower potential e to the power minus of t by 2 divided by 1. Correct? If we know this current, we can calculate the current in capacitor. What is current in capacitor? Incoming current minus this current. So you can say incoming current is I1 minus current in half ohm resistance will be the current in 1 farad capacitor, and that current is I1, which is e to the power minus of t minus e to the power minus of t by 2 minus 2 e to the power minus of t by 3 is the current which is flowing in this branch, and that current is e to the power minus of t minus 3 e to the power minus of t by 2. This is the current we are having. And when you look at the circuit at t0 plus, you can say at t0 plus this value is 1. And at t0 plus this value is also equivalent to 1. So this current is 0. Current in this branch is what? 2 ampere. And this 2 ampere will go in opposite direction. That's why it is representing minus 3. So our all result will be correct. Let's verify the result. What I am saying, let's verify this results. What this results is trying to tell us. These results are trying to tell us that if I draw this circuit at t equal to 0 plus moment, just after the switching, if I draw the circuit at t equal to 0 plus, can I say how my circuit will looks like at t equal to 0 plus? So you can say that here you are having 1 volt, then you are having 1 ohm, then you are having 1 by 2, this is 1 ohm. And what is initial condition of the capacitor? Initial condition of the capacitor is given as 0.5 volt. Okay, we made one mistake here. This value is e to the power minus t by 2, not e to the power minus. This is e to the power minus t divided by 2 is the correct value. So we need to modify this calculation here also. It is e to the power minus of t divided by 2. We have solved it correctly, but by we have correct solution, but by mistake we have taken it e to the power minus t by 2. And if this is the condition, let me write it. Let me rewrite the solution. What I can say, if it is e to the power minus t by 2, what is current coming from here? The current coming from 1 ohm resistance is e to the power minus of t minus e to the power minus t by 2. Again I am doing it wrong. Minus t by 2 divided by 1. What is current in half ohm resistance? Current in half ohm resistance is given by e to the power minus of t divided by 2 divided by 1 by 2. So this value is what? E to the power minus of t. Correct. So what is this current? This current is e to the power minus t. So e to the power minus t by 2 is the current in e to the power minus t divided by 2. And what is current here? E to the power minus of t. So what is current in 1 farad capacitor? The current in 1 farad capacitor is given by incoming current minus current going into this branch. So incoming current is what? E to the power minus of t by 2. Incoming current is what? Incoming current is e to the power minus of t by 2. And current going in this branch is e to the power minus of t. So current in 1 farad is given by minus e to the power minus of t by 2. And you will see all this current, this differential equation is valid for all the solutions, all the values of t. So can I say if I draw my circuit at 0 plus, then I can say my circuit will looks like this. Correct. This is our circuit at t0 plus, and at t0 plus this potential is what? If I consider my bottom potential, this junction as V reference, if V reference equal to 0, what is potential here? Potential here is 1 by 2 volts. So what is current coming from here? 1 by 2 ampere. What is current going in this branch? 1 ampere. So what is current going inside this? The current going inside coming to this node is half ampere. And you can verify this result. Incoming current is 1, but outgoing current is only half ampere. So who will supply? Incoming current is half and outgoing current is 1 ampere. So who will supply remaining half ampere? Because there is no current is going in this branch. So this 1 by 2 volt source will supply the half ampere. And exact direction of current we are having from our expressions also. Our expressions are also giving the same result. When you put I1, what is the expression of I1? The expression of the I1 from our analysis is e to the power minus of t by 2. And e to the power minus t by 2, when I put t equal to 0, this value is 1 by 2. As mentioned by this circuit, it is 1 by 2. What is the value of I half ampere? What is the value of I half ampere? This current is given by e to the power minus t. So this value is what? If I take t equal to 0, it is 1 ampere. And what is current here? A current in 1 farad is given by minus e to the power minus of t by 2. If I put t equal to 0, minus 1 is there. So this current is opposite of the previous current, our mentioned direction. If this current is opposite of our mentioned direction, can I say all currents are valid for, and we can calculate everything across every component of this circuit. I hope this is clear. In the first order analysis, let's take one more example and how this example looks like. One more example. These are conceptual questions. After that, we will start the question which we will solve using time constant theory. Okay. We are having one circuit. Here the value is V naught. And the value of V naught is 3 volt. The value of V naught is 3 volt. What else is given? One resistance is given as R1 and value of R1 is 10 ohm. One more value is R2. R2 is given as 5 ohm, and one inductor with switch is given. And what is value of this inductor? The value of inductor is half Henry. And what question is asking? The question is asking VA of T. What is VA of T? VA of T is the voltage across inductor. And how your switch is working? The initially switch is open and it is closed at T equal to 0. Initially switch is open, it is closed at T equal to 0. It is closed at T equal to 0. So how we can analyze this circuit? Okay, fine. So again, there is a conflict because we are having energy storing element as inductor, but they are asking the voltage. So we don't analyze the circuit at T less than 0. We will just analyze the circuit for T greater than 0. And no initial condition is given for inductor. Yes, no initial condition. So initial condition for inductor is condition for inductor I0 minus is 0. It is given that no current is stored inside the inductor. This is the whole story. So can I say we have to analyze the circuit for T greater than 0. So for T greater than 0, the switch is closed. The switch is closed. If switch is closed, we can have this kind of circuit. This is 3 volt. This is 10 ohm. This is 5 ohm. And we are having one inductor, and this inductor is having value half Henry. And we are interested in this voltage. This voltage is VA of T. Correct? This voltage is what? This voltage is VA of T. Now, if I assume this potential as, our reference potential, if I consider this potential as our reference potential, V reference, then what I can say, the value here will be what? VA of T. And all points are short circuited, so you can take these are all short circuited points. So single node is valid for this. Now I am interested in what? Now I am interested in writing KCL. So what is KCL? KCL is given by VAT minus 3 divided by 10. VAT minus 3 divided by 10 is current in this direction, plus VAT divided by 5 is current in 5 ohm resistance, plus 1 by L integration of V dt. 1 by L means 2 integration of VAT into dt. This is the current going inside the inductor. And sum of all this current is equivalent to 0. Why sum of all this current is equivalent to 0? The sum of all current equal to 0 because the current going or coming to this branch is also equivalent to 0. So when I calculate this, when I differentiate this, 3 VAT by 10 plus 2 VAT by 10 is 3 VAT by 10. Let me write this. 3 VAT by 10 minus 3 by 10 plus 2 times of integration of VAT dt. When I differentiate both sides, can I say this is 3 by 10 dVAT divided by dt plus 2 times of VAT equal to 0. Or you can say, if I take this coefficient as 1, dVAT divided by dt plus 20 divided by 3 VAT, this value is equivalent to 0. This is again a differential equation which you can solve by, this is again one differential equation, and you can solve this differential equation by what? Variable separation method. Variable separation method. So what is the final value of VAT? VAT can be written as some constant times of e to the power minus of 20 by 3 into t. And always remember, what is the time constant? Time constant is 3 divided by 20. When you put this ratio, this product equal to 1, the value of the value of t will gives you the time constant. So can I say VAT is minus 20 by 3 into t into k. Now can we find the value of VAT? So you can say how your circuit is behaving at t0 plus. You cannot copy the condition from before switching to after switching. And why we cannot copy the condition? We cannot copy the condition because we are having energy storing element as our inductor, and inductor cannot copy the current. So you can say we have to draw the circuit for t equal to 0 plus. And if we draw the circuit for t equal to 0 plus, how circuit will looks like? The circuit will looks like this. This value is 3 volt. This value is 3 volt. Then we are having 10 ohm. 10 ohm. Then we are having 5 ohm. And if initial condition of the inductor is stored current is 0, then can I say I can replace this inductor by what? I can replace this inductor by short circuit. And I can call this voltage, because this circuit is only valid at T0 plus. So you can call this voltage as which voltage? VA0 plus. And what is VA0 plus? The value of VA0 plus is given by this. You are having 2 volt and you want to divide it into 2 ratio 1. So you can say I0 plus current is given by what? 3 divided by 15. Potential difference is 3 and resistance is 15. So current is what? 1 by 5. And 1 by 5 will go into 5. So this potential is what? 1 volt. So you can say the initial condition of the circuit is known, and VA0 plus, it is 1 volt. If VA0 plus is 1 volt, can I say what is solution of VAT? The solution for VAT of our circuit, the voltage across inductor for t greater than 0, and this voltage is given by what? This voltage is given by 1 into 1 into what? E to the power minus of 20 by 3t for t greater than or equal to 0. If you know the current across inductor, you can calculate voltage across inductor, you can calculate the current across inductor also, because what is our circuit? You can say our circuit is for t greater than 0. Our circuit looks like this. This is 3 volt. This is 3 volt. Then you are having one resistance of 10 ohm. Then we are having one 5 ohm resistance. And then we are having one inductor. And what is value of inductor? The value of inductor is half Henry. And it is given that the voltage across each component is given by e to the power minus of 20 by 3t. If this value is given by 20 by 3t, can I say if this value is minus 20 by 3, we can calculate the current in this branch. We can calculate the current in this branch. Let me call this current as I1. Let me call this current as I2. What is the value of I1? So you can say the value of I1 is given by 3 minus e to the power minus of 20 by 3 into t divided by 10. What is the current I2? The current I2 is given by e to the power minus of 20 by 3 into t divided by 5. And can I say I1 current minus I2 current is the current which is going inside the inductor. So you can say the current across half Henry inductor is given by I1 minus I2. And if you find the I1 minus I2 at t equal to 0, this value must be 0. 2 minus 1. 2 minus 1 is 3 minus 1 is 2. 2 divided by 10 is 1 by 5. And minus 1 by 5 plus 1 by 5 is cancelled. So incoming current equal to outgoing current, because what is the current? This equation must satisfy this value, that what is the current in inductor at t equal to 0 plus, and that current must be 0. So when I say what is I1 at 0 plus, so I1 at 0 plus is 2 by 10. What is I2 at 0 plus? It is 1 by 5. So this difference is what? This difference is equivalent to 0. So you can verify from our equations that total current going in the inductor is given by what? If I am interested in the inductor current for t greater than 0, this value is 3 minus e to the power minus 20 divided by 3t divided by 10 plus e to the power minus of 20 by 3t divided by how much? Divided by 5. And what is in between sign? In between sign is negative, not positive. So let me use a negative sign here. This is the amount of current going into the inductor. If amount of current going into the inductor, so you can say IL is equivalent to 3 by 10 minus of e to the power minus of t by tau, where tau is given by 3 by 10 by 10 minus, it is 1 by 5, so I am multiplying it by 2 and dividing it by 2. So e to the power minus of t by tau divided by 10. And this expression is also valid for t greater than or equal to 0. So you can say the value of IL as a function of time is will be what? 3 by 10 minus 3 by 10 into e to the power minus of t by tau. This expression is also valid for t greater than or equal to 0. And when I take 3 by 10 as common, this value is what? This value is 1 minus e to the power minus of t by tau. And this is valid for t greater than or equal to 0. So now we know the current across every component. Now we know the voltage across every component. Now we are having a good understanding of this circuit, how this circuit is behaving with uh, with time. So we can draw everything also. So how what is the situation of the voltage? So situation of the voltage is VA is what? E to the power minus 20 by 3. So you can say VA is given by for t greater than or equal to 0. So can I say how you will draw this? This is the voltage across inductor. This is the voltage across inductor. And how you define the voltage across inductor? What is the initial value? Initial value is 1 at t equal to 0, and after that it is going exponentially decaying. And what is time constant? Time constant is the time required by this process to reach 1 by e of its maximum value is time constant. So you can say time constant is what? 3 by 20. In tomorrow's session I will use this time constant exclusively to write answer directly, so keep this thing in mind. What is next thing we have to understand? The next thing we have to understand, what is the position of current across the inductor. And can I say the position of current across the inductor is given by this. If we are interested in current, how you will draw the current? The current across inductor is given by 3 by 10 1 minus e to the power minus of t by tau, where tau is something which is known. So what is the value of current at t equal to 0? At t equal to 0, the current is also equivalent to 0. And when t is approaching to infinity, current is what? 0.3 ampere. So 0.3 ampere is the current which you will have in a steady state. So this is the current you are having in the circuit. These are two waveforms. So can I say in steady state, when steady state is achieved, the inductor is behaving as a short circuit. And what is the current inside the inductor? The current inside the inductor is 3 by 10 ampere. This is two waveforms representing the voltage and current across the inductor. You can analyze this too. Means when you achieve the steady state, when inductor will achieve the steady state, the current is constant because one source is connected to the inductor, and the voltage is what? Voltage is short circuited. Now uh, let's draw the remaining parameter. What is situation of current across I1? What is the situation of current across I1? And the situation of current across I1 is given by, let's say I am interested in I1. And what is I1? I1 is current coming from the source. So I am calling this current as 3 by 10. 3 by 10 minus 1 by 10 into e to the power minus of t by tau. So when I draw this graph, I can draw this graph also. what is the situation of current coming from the source? So can I say the source current is having this characteristics? What is the initial value when I this is I1. So when I am saying t is equivalent to 0, when t is equivalent to 0, this current is what? 3 by 10 minus 1 by 10 is 2 by 10. And in steady state, this current will be what? In steady state, this current will be 3 by 10. So can I say this current is going from, this current is going from 2 by 10 to 3 by 10 in steady state. So current across resistor, current coming from the source is increasing. Current coming from the source is increasing from 2 by 10 to 3 by 10. And you can write the voltage also. What is the voltage across? If I write this voltage as V1, what is the position of V1? So you can say the position of V1 is very simple. If this voltage is e to the power minus of 20 by 3 into t, so can I say V1 voltage is what? V1 voltage is the voltage across which resistance? Voltage across the resistance 10 ohm, and this voltage is what? 3 minus e to the power minus 20 by 3 t. And we can draw the voltage also. So what is the voltage at t equal to 0? As you know that all differential equations are valid for t greater than or equal to 0. But suppose I am interested in the voltage. So how I can write the voltage V1? So at t equal to 0, what is the situation for the voltage? At t equal to 0, this voltage is 2 volt. When you put t equal to 0, this voltage is 3 minus 1. 3 minus 1 is what? 2 volt. This voltage is 2 volt, because when we write V1 at t equal to 0, this is 3 minus 1. 3 minus 1 is 2 volt. And when we put t equal to infinite, this value will go to 3 volt. So can I say this is the condition of the voltage here? In a steady state, what is the potential drop? The potential drop is 3 volt. These are the waveforms for the current across the resistance. And what is next? The next we are having what? Next we are having the one more component is there, and that component is I2. So what is I2? So potential across I2 is same as potential across inductor, because both the components are connected into the parallel. But what is the situation of current? So you can say I am calling this current as I2. So if I draw the I2, what is value of I2? I2 is given by e to the power minus of 20 by 3t minus 0. This is the potential difference divided by resistance. And what is the resistance we are having? We are having 5 ohm resistance. When you look at this, what is resistance here? 5 ohm resistance. And what is potential across it? Let me call this potential as V2, but V2 is same as VA, because VAT, because these components are connected in the parallel, and this potential is e to the power minus of 20 by 3 into t. If I draw the waveform across I2 and V2, how I2 and V2 looks like, so you can say if I draw first the voltage waveform will looks like this. This is V2, or we can say these are connected in parallel. So inductor voltage and resistance voltage will be same. At t equal to 0, this value is 1 volt, and after 1 volt it will goes to, from 1 volt to it will go to 0 volt. This is the condition of voltage across inductor. And next thing we are having is current across inductor. So at t equal to 0, current is 1 by 5 ampere. We can say what is current across what is current across resistance. So let me draw the current also, and that current is different. This current is I2, and what we are saying, when we put t equal to 0, this current is what? This current is 1 by 5 ampere. And as you increase the value of time, the current will goes to 0 ampere. This is the total analysis of the circuit. Means how every component of the circuit is acting in the circuit. Means if potential across inductor is going exponentially decay, the current will increase. Then because this is the nature steady state, how it will attain the steady state? In a steady state, uh, it will behave as a short circuit. What is the behavior of the current coming from the source? So I1 is the behavior of current coming from the source. And what next thing represents? The next thing represents one in between resistor which is connected. So voltage is going from 1 to 0 and current is going from 1 by 5 to 0. So this is the total analysis. Means in GATE they can ask any question, and they can ask question related to the power also. So we'll talk about the power in the next session. And today's session, this is analysis of the circuit in totality without any shortcut. And what are the concept? Only two types of concept is useful in this analysis. First one is initial condition, of energy storing element L and C. And second one is first order differential equation. First order differential equation with constant coefficient. Only these two concepts can solve all the questions, all the variety of questions of transient. I hope this session is clear. Thank you very much.